Hello, good morning. Today we are going to see pointers in C++. What is pointer? A pointer is a variable which stores the address of another variable. For example, integer b equal to 10. B is the integer variable, holds the integer data 10. Technically, we may say a variable is a name of the memory location. See the diagram. The variable b is stored in the memory location 1000. That is, b is the name of the 1000th location. Declaring pointer variables. In the declaration statement itself, it is necessary to specify which type of data the pointer should point to. Format type as is symbol variable, where type is the data type of the variable the pointer points to. For example, integer as is p1. Here p1 is the pointer. Okay. Int, that is integer b is an ordinary variable. p1 equal to address of b, that is p1 holds the address of the integer variable b. See the diagram. B is the ordinary variable, it contains the data 10. p1 is the pointer which points to the ordinary variable b. Okay, and the address of b is 1000. Next one, reference or address of operator. The address that locates a variable in memory is what we call a reference to that variable. This reference to a variable can be obtained by proceeding the variable with an ampersand sign known as reference operator, and this can be read as address of. Dereference or indirection operator. By using a pointer, you can directly access the value stored in that variable which points to. To do this, you simply have to proceed the pointer with an asterisk symbol, which acts as dereference or indirection operator, and this can be read as value pointed by. So if you write integer a1 equal to indirection operator p1, we would read as a1 equal to value pointed by p1. So a1 takes the value 10 because the address of b is 1000 and the value stored in that address 1000 is 10. A simple program to explain the address of operator. As usual, we are including iostream.h, coney.h means console input output. Here we are declaring one ordinary variable integer b equal to 5. In integer p, here p is the pointer and p equal to address of b. Pointer b stores the address of the variable b. See what address of b is. Here the address of the variable b will be displayed. See the program, and this program display the address of the variable b. Next one, a simple program display the indirection operator. The same program, here we are using indirection operator. So instead of address, here the actual data will be displayed. See the program taken from the compiler. So the value of b is 5. Int b equal to 5. Int r is p. P is a pointer. Value of b is indirection operator p. So what will happen? What's the value of b? 5. What's the address of b? 1000. So 1000 will be stored in the pointer variable p. So star p will be replaced by the address 1000 and the star 1000 will be replaced by the data 5. So 5 will be displayed. Next one, addition with pointers. We know the pointer stores the address of another variable. So if you add one to a pointer means it will point to the address of the next data, not the next memory location. For example, if a pointer points to a character data and if you add 1 to it, then it will point to the address of the next character data. Similarly, if a pointer points an integer and if you add 1 to it, then it will point to the address of the next integer data. Similarly, if a pointer points to a float data and if you add 1 to it, then it will point to the address of the next float data. See the diagram. Assume the characters S, C, R, E, N and the integer data 100, 150 and 200 are stored in different memory locations as shown below. The pointer CP and IP are points to the location 1000 and 2000 as shown below. Okay. Starting from the memory location 1000, the set of characters S, C, R, E, N are stored. Similarly, starting from the memory location 2000, the set of integer data 100, 150, 200 are stored. Okay. And the pointer CP points to the location 1000 where the character S is stored. Similarly, the pointer IP points to the memory location 2000 where the integer data 100 is stored. Now, the pointer CP points to the character data and the location of S is 1000. The size of character data is 1. You already know the size of the character data is 1. So, if you add 1 to it, then the pointer will point to the next memory location 1001. Similarly, the pointer IP points to the integer data 100 and the location of the data is 2000. So if you add 1 to it, then the pointer will point to the next memory location 2002, not 2001, because the size of integer data is 2. Similarly, pointer addition with float data. The pointer FE points to the float data 10.5 and the location of the data is 3000. If you add 1 to it, then the pointer will point to the next memory location 3004, not 3001, because the size of float data is 4. Program. Here, this program, there are 3 arrays, one character array display, one integer array A, one float array FT. In the character array, 3 characters are stored, T, C, S, and the character array should be ended with a null character. You already studied in C, C++, right? All character arrays should be ended with a null character. And the integer array A stores 3 data, 100, 150, 200, and the float data FT stores 2 real data, 10.5, 12.5. And in this program, we have declared 3 pointers, CP, IP, and FP. So CP points to the starting address of the character array display, and IP points to the starting address of the integer array A, and the pointer FP points to the starting address of the float array FT. Now, CP points to indirection CP. So what will happen? What's our indirection CP? So it takes the address stored in CP 1000 and what's the data stored in 1000? T. So T will be displayed. Then indirection IP. So it will take first it will take the address to 2000. What's the data stored in 2000? 100. So 100 will be displayed. Then similarly 10.5 will be displayed. Now we are adding 1 to all pointers. CP equal to CP plus 1, IP equal to IP plus 1, FP equal to FP plus 1. So after adding 1 to all pointers, let us see what data will be displayed. Is the program. So before adding 1, T 100, 10.5 will be displayed. After adding 1 to all pointers, the next character, next data will be displayed. That is C 150, 12.5 is all displayed. Because we have added 1 to all pointers, right? So you will get this data C 150 and 12.5. Next one, pointer to pointer, double pointer. A pointer which points to another pointer. So in C, C++, we can define a pointer to store the address of another pointer. The first pointer is used to store the address of variable, whereas the second pointer is used to store the address of the first pointer. So we can declare pointer to pointer in double asterisk symbol. double add symbol p. See the diagram, integer a equal to 10, ordinary variable. Then int as the symbol p, single pointer, then double add is pp, that is pointer to pointer or double pointer. P equal to address of a, pp equal to address of p. The pointer pp points to the another pointer p, and the pointer p points to the ordinary variable a. See the diagram. The program. So int address p, single pointer, double address pp, double pointer. So p equal to address of a, p equal to address of p. Here value stored at a, single index operator p, next one double index operator pp. So the data 10 will be displayed, 10 will be displayed. First time also 10, the second time also 10 will be displayed. So address of a is 1000, address of p is 2000, value stored at a is 10, value stored at a is 10. See the diagram. The pointer p points to the location 1000, and the data stored in that location 1000 is 10. So 10 will be displayed first time. See this diagram. PP is a pointer to pointer, and this PP points to the another pointer p, and that single pointer p points to the location 1000. And what's the data stored in 1000? 10. So this time also 10 will be displayed. Next one, we can do the following tasks by using pointers. By using pointers, we can access array elements. We can pass arrays and strings to functions. We can obtain memory from the system. We can create data structures such as linked list. We can pass arguments to a function when the function needs to modify the original argument. We can reduce the number of loops in a program. Pointers can only use to the following operators: addition, subtraction, assignment, equal to, indirection, arrow, increment, decrement. That is, we cannot use pointers for multiplication and division. Let's see one simple program. Program to interchange two variables using pointers. Here I have declared two ordinary variables a and b, and I have declared two pointers p1 and p2. p1 equal to address of a, p2 equal to address of b. Now we are entering values for a and b. So before interchange, a equal to 5, b equal to 10. After interchange, here we are going to interchange the values of a and b. For interchanging values of a and b, we can just change the pointers. Here, simply I can change p1 equal to address of b, p2 equal to address of. Simply I will change the pointers. Then the value will be interchanged. So after interchange, a equal to 10, b equal to 5. Very simple. But if you use pointers, it is very easy to interchange two variables. Types of pointers. There are different types of pointers are there: null pointer, virtual pointer, dangling pointer, void pointer, wild pointer. Null pointer. Null pointer has a reserved value that is called null pointer. That pointer does not point to any valid object or function or data. The pointer points to null. Null means empty, void, right? So the pointer doesn't point to any valid object or function or data is called as null pointer. Then virtual table and virtual pointer. What is virtual table? A table created at compile time for every single class containing the most derived versions of virtual functions. Virtual pointer. A data member silently inserted by compiler into the class specification and initialized to virtual table from within the constructor. Dangling pointer. Dangling pointers arise during object destruction. When an object that has an incoming reference is deleted or deallocated without modifying the value of the pointer, so that the pointer still points to the memory location of the deallocated memory. Wild pointer. Wild pointers are different from pointers, that is, they also store the memory address but point the unallocated memory or data value which has been deallocated. Such pointers are known as wild pointers. A pointer behaves like a wild pointer when it is declared but not initialized. Advantage of using pointers. Program execution time is reduced. With the help of pointers, we can create data structures like linked list, returning more than one value from functions, searching and sorting large data very easily, allotting memory dynamically. Disadvantage of pointers. If pointers are referenced with incorrect values, then it affects the whole program. Memory leak occurs if dynamically allocated memory is not freed. Segmentation fault can occur due to uninitialized pointer. Thank you. Please subscribe my channel. You may contact me at unboot666@hotmail.com.